Wind turbines, what we've got here, hydro turbines, which are also similar to wind turbine. We've also got a pedal generator here, which we will try and wire up later. So, renewable energy, everyone says it's a great thing. I quite like it. It's inherently distributed. There is generally some form of renewable energy available everywhere. Obviously, it's very resource location dependent, so depends on where you are. In the UK, we don't get that much sun. We get a bit, but not so much. So generally, there's some form of renewable energy available locally, but you have to do a local resource assessment. Using renewable energy can buffer you from fluctuating fuel costs. These benefits have generally been written for developing countries of why you would be using renewable energy. In the UK, generally we're looking at global environmental benefits, so we're looking to reduce our carbon dioxide to try and stop climate change. There are local environmental benefits, so you're not burning things in the local environment. Generally, when I was in the Philippines, lighting in remote places would be a kerosene light, which is very, very, very dirty form of light. And as soon as you change that to a different form of light, say LEDs in a solar system, then you actually get local environmental benefits. You also get local health benefits. It's generally the women and kids who are in the room where they've got the burning light and they hang around in there all day and they get coughs. Respiratory diseases are the biggest killer of children under the age of 5. Quite amazing, but that's nearly all to do with, well, it's mainly to do with fires rather than kerosene lights. But, can anyone think of any problems with renewable energy?
Expensive.
Yeah, true. It is. Depending on the location. In remote area, it can be very economic to install a renewable energy system. You buffer it from local food costs. So yeah, it varies, but yeah, generally it's quite expensive initial cost.
A lot of them require materials that need large amounts of fossil fuel inputs to produce.
True.
So.
Kind of what? That is true. Aluminium in a solar panel, obviously very high embodied energy. Generally, some facts and figures on embodied energy of, I think solar PV has the highest embodied energy. From what I've read, people have quoted times of, so embodied energy is the amount of energy required to make something, and then you compare it to the amount of time it takes to repay that energy from the output of the device. For a wind turbine, a large-scale wind turbine, it's generally about 6 months to a year. That's a large-scale wind turbine. Small-scale wind turbines, I don't really know. Depends. If you're making things like this from wood and, generally, or scrap materials as well, much lower embodied energy. Solar photovoltaics, depends on the country, depends on where you're using it, depends on how much energy you're getting out of it. I've seen quoted payback times from about 1 year. In the UK, it's between 6 and 10 years. So the embodied energy of a solar panel will take 6 to 10 years of that solar panel being used before it will actually give you any surplus energy. It will actually be any carbon dioxide potential saving.
What's the expected life of a solar panel?
So expected life of solar panels is generally about 20 years. Ones in CAP have been running for 30 years, 30, 35 years. A lot of manufacturers guarantee them for 20 or 25 years.
So they're still pretty good then, even if you're using a pretty rubbish place.
Yeah, exactly. The UK, pretty rubbish place. Generally, you will get about twice the amount of energy out of it than's gone into it. That does depend upon you having it out in the sun. I think these ones are going to have a very low yield because they're kept in a box quite a lot of the time. What else happens with renewable energy? So say we're relying upon the sun and yet we've all got light bulbs on the table. How useful is that? So what happens? What happens with the renewable energy? It's not it's variable basically. So I'll come on to the main problems of integrating renewable energy into an electrical system are the fact that the supply varies, your resource varies. You can't shovel more coal on because you can't turn up the sun. It's there or it's not. It's night time or it's not. Wind turbines wind resource is very variable over the seconds. It can vary. You also have variation in demand, so you don't need to have things turned on all the time, so you can actually control things by controlling your demand. We've also got this thing called aggregation, which my slide for this doesn't come out very well. Aggregation is when you've got lots of small generators, or lots of generators together, what actually happens with the stability of a grid. So here we have some typical variations. So first one that's quite easy to see, solar radiation varies generally from sunrise to sunset. It goes up and comes irradiance level. Generally follows this curve. Obviously if there's a bit of cloud, it can go up a bit, but it's quite predictable. You can predict what's going to happen. Wind turbines, so this here is the output from I think 2 wind turbines. I think it's that one. Or is that the wind speed? Anyway, basically it's incredibly variable on a scale of, this is 1 hour, but you can see it's varying up and down. I've seen wind, been watching our power output from the wind turbine, and it's gone from about 10 kilowatts to 50 kilowatts in a second. They're just huge variations, and you have to deal with that. So if you've got an electrical system, it has to deal with that. Also, this is a typical domestic house, starting, what's that, 6 o'clock in the evening, going to 7 o'clock in the next, oh no, I can't read it anyway. Bit of time over the day, you've got a refrigerator turning on, you've got a cooker turned on, you've got your hot water, you've got your immersion heater turned on. Things turn on and off. We consume energy all the time. I've got my computer on here, there's a random left on computer here. You know, we turn things on and off, so we vary the load. And that makes it very difficult for us to control an electrical system, because as we vary the load, the voltage and current will be going everywhere, and we have to solve that somehow. So basically what we're trying to do is match supply with the demand. So there are certain times, this is a great graph, so our supply drops beneath what we actually require, so we have a deficit, and sometimes we have too much, which we have an excess. Simple to kind of comprehend, but actually very difficult to deal with in real life. Has anyone been watching, very good programs recently about the national grid? Everyone's really interested in stuff. There was a very good series of programs about the national grid on BBC 4, I think. Yeah, it's on download anyway. Very interesting. It shows you the control room where they actually look. They've got all the TV channels on. They've got TV guides. They know various things that are happening. They know the timetable of the Eurostar. So when that turns on, that's the biggest single load in the UK. So there are, various things that they know turn on and off, and the times at which. And there's basically a few guys in a room who go, "Oh, turn it up a bit, turn it down a bit." I know it actually is like that, and they're there actually looking at the TV guide. "Oh, Coronation Street's just turning on. BBC finished EastEnders earlier. People are going to be turning on their kettles." It's quite hilarious how it comes down to a few guys in a room.
What happens if they get it wrong?
That's true. I'm sure there are times when they got it very wrong. The issue is to do with, if you can predict it, you can produce very cheap power. If you can't predict it and you have to turn on emergency power, it costs them a lot of money. So they can do it. There's a place called Renewables in Wales, which is a pumped hydro system, and that can supply huge amounts of power very quickly. So that can pretty much buffer all that. But buying power from them costs them a fortune. So if they can possibly avoid it, they will. So that's, and you can also dump power. You can turn off loads. You can also turn on loads. So there's aluminium smelting plants, and there's industrial loads with big heaters where they have much cheaper electricity because they can be turned on and off at any time. There are ways of doing it, and generally we're never getting there. Well, there is a potential for it all to go wrong, and we'd have a blackout. And we have